Okay, so we have a version of a simple paper-controlled electric field hockey. And so we made this all in the creator interface. We have a group of 4 different charges. Each one of these is its own paper. We have 3 sort of obstacles or walls that we can put in. And then we also added added an outer bounds. So just a bound that goes around the outside of the window to let us know when our test charge goes outside of it. And the test charge itself. And in here, in this program, we have the test charge position, its charge, which will be positive for the purposes of this. It'll calculate the electric field magnitude, give us a X and Y component of the force, and we'll use that to drive the animation. So we'll calculate the new position every frame to see where the test charge should go based on the forces it feels from each of those 4 test charges, or for the 4 charges. And then we gave it some a little shape too. And each of these charges here has its position and a charge. The position is controlled by a controller component that just ties it to the paper position. So we move the paper, move the charge. So we've already got these sort of set up. Here's the camera page. We made the test charge paper and the bound, the sort of outer bound, the view bound, as virtual papers because we don't need to move those around at all. And then all the rest of the papers are in the view, are in the camera as real physical papers. So let's go ahead and go in here. I'm going to turn the sound back on. You'll start to hear a little bit of sound. So coming around here, we have our projector up there with the camera doing some detection. And yeah, so the test charge right now, it starts off on this side of the screen right here, and it's feeling the force of a positive charge, which is right here, a little blue circle. Each of these green boxes here, which are drawn on and are very sizable, are the walls. So right now there's a wall in the way of this of the test charge that's feeling this positive charge right here. And over here we have 2 negative charges, so positive test charge is being attracted over this way, positive here, and another positive up in that corner. So if I were to try to move this around a little bit to keep the test charge from hitting those walls, we could of course move the walls. And you'll hear a sound here that I just kind of simply mapped to the magnitude of the electric field. So it's going to go lower the less it feels. You can kind of correlate that there with that sort of the acceleration that you see of that test charge. Okay. All right, we could try bringing the positive one closer. That's just going to push it that way. All right, so that's not going to work too great. How about moving test charge over here? Well, probably needs a lot more force in the positive X direction. So let's just drop that over here. There we go. And it zips on over to that negative charge. Well, right through the corner that we wanted. So that works out. So then if I move this negative one over here, yep, right, then that force is going to pull it up this way. Just missing the barrier, and up there. Very cool. So yeah, we can move these things around. Again, we can make the barrier a lot bigger here. Could probably drop this in the middle, and then it's going to try to hit that. Yep, it's going to try to hit that barrier. I could probably drop it over there instead, and that's feeling a little bit too much force in that direction. Oh, we lost. Oh, I just covered up that one. There we go. I covered up the positive one accidentally, so we lost its force. Yep, so a little bit too far in that direction. If I move this down, we should get it coming back a little bit. A little closer. Not quite enough. Still not quite enough. Let's bring this down a little bit, the positive one. Oh, I screwed it just along the side. Awesome. Well, I'm going to turn off the sound for a second. Let's try adding something more to this. I'm going to tilt this camera back up. Let's go back into Creator. I'm not sure how much is going to be visible here. Keyboard just misbehaving. Let's go ahead and add a simple description. How about that? So I'm going to click on the test charge and try to go a little closer here. The test charge paper, and let's create a component. And this is going to be a view because it's a speech. And let's see, we're going to want description or speech. And what's a simple one? Let's do that reset. Whenever the charge hits a wall or goes out of the bound, it resets on the side. How about we add something for that? So reset. I'll just call it reset speech for now. Alright, so I know that this needs to reset anytime, or this needs to speak anytime we hit the bounds or the outer view. And I know I already wrote that code, and I did that with the help of the AI. So I'm actually going to create this just so it's there, and I'll just have it return nothing for now, just so I can create the component. And then I'm going to go to where I know I've used that code, and that's in the animation component, where anytime it hits those bounds, it actually does the resetting. So I'm going to go ahead and just copy all this because it's the same cases. And let's go back over to that reset speech component that we made. And we're going to plop that in. And now, of course, I want the same conditions, but when that happens, I want it to play the speech instead. I don't think I need the LLM to do this, because I think I just want it to play in these same cases. So if I hit a bound, one of the obstacles, then I want to return, let's see, wall hit position reset. Okay, that works. I'm going to copy that. If it hits the outer bounds, I don't want it to do anything with the test. Nope. Sorry, my mouse is misbehaving a little bit. There we go. I don't want it to do anything with that. I want it to change I want it to say something. So I'm going to delete that and copy that line. So if it goes outside the view bounds, we'll just say left window position reset. Sure. And otherwise, we don't want to say anything at all. So else, and I think here we can just kind of leave that blank. So I'm just going to erase those lines. I think that'll work. So let's give it a shot. So let's save. And oh, I totally forgot to assign the components here. Oh, I'm sorry, my mouse is on the fritz here. So we needed all of those different bounds. So we need the obstacle 3 bounds, obstacle 1 bounds, obstacle 2 bounds, and then we have the outer bounds. View bounds is what I call those. And I can come down here and just check that I didn't use anything else. So view bounds, obstacle 1 bounds, obstacle 2, oh, and test charge position. We're going to need to know where the test charge is. So let's go ahead and grab that one too. Okay, so now I should be able to see all of those, and we'll actually be able to use those functions. So let's just save it. Okay, let's save the project just in case. Now we're going to send a playground. Okay, let's come back to here, and I'll turn my sound back on. And... oh, alright, we're back. So, my bad. My reset speech code was a little bit backwards. It was not supposed to play in that middle case, because if it's in the view bounds, then that's always, so it was overriding itself. We switch that for any case that it leaves. And so now, if we come on over, hit the wall, wall hit, position reset. We'll move that out of the way a little bit. Let it kind of go out of bounds. Left window, position reset. Okay, that's it. Perhaps I should have used the LRM, huh?